Hello everyone, Aaron here, and welcome back to Leetcode. Today we are doing the integer to Roman problem. Not the Roman to integer problem, this time we're taking numbers and turning them into Roman numerals. So, Roman numerals are represented by 7 different symbols. I, V, X, L, C, D, M. 1, 5, 10, 50, 100, 500, 1000. For example, 2 is 1, 1. 12 is written XII. The number 27 is written as XXVII. Roman numerals are usually written largest to smallest from left to right. However, the numeral for 4 is not III. Fun fact, if you go to the Colosseum, you will indeed find an entranceway numbered III, because this was in fact the way Roman numerals were written for hundreds of years. Anyway, that's not the version we're writing here. We are instead saying 4 is IV. Same principle applies to number 9, IX. There are 6 instances where subtraction is used. I can be placed before V and X can go before L and C can go before D and M, so on and so forth. So 3 is III, it's easy enough. Num is 58, so that's 50, 5, 6, 7, 8, 1994, oh, my birth year, is MCMXCIV. So the number is going to be below 4,000. That's good, because otherwise we'd need to know how to write 4,000. And I don't know the Roman numeral for 10,000 or the 1,000 or the 5,000 Roman numeral. So we stop before we hit anything too tricky. So it works mod 10. These things are the mod 10. These things are the mod 100. These things are the mod 1000. So I think what we want to do is do a convert with symbols. Self num unit half unit half whole, I guess. So the idea here is basically that number is a number from 0 to 9, or yeah. Unit is I X C. Half is going to be either V. This could, well, no, it can't be M. Well, no, it could be M. V L D. Whole is going to be X C M. And the way I'm thinking here is basically that if num is less than 4, return num unit times num. And if num equals 4, return unit plus half. And if num equals 5, return half. Num equals 9, return unit plus whole, else return half plus unit times num minus 5. So the reasoning here is, let's do this with convert with symbols of num mod 10, and we'll feed it I, V, and X. Now in this case, obviously it works. If it's, in fact, hang on. If num is equal to 0, return the empty string. That's a special case that we need to be aware of. They couldn't write 0, basically, with this system. And if we want to do a 50, for example, we don't want any... Once we've written the 50, we don't want to write anything else to signify the 0. So, for the basic numbers, this is straightforward. We're going to get 0 is going to be empty. 1, 2, or 3 are going to be 1, I, and I. 4 is going to be IV. 5 is going to be V. 9 is going to be IX. And 6, 7, 8 are going to be V and I repeated 1, 2, or 3 times. I think that works. So then what we need to do is actually go, while num does not equal 0, in fact, no, for, what we want to do is for unit, half, whole in symbols, in fact bases, we want to call this with unit, half, whole. We want to do a right concatenation, sorry, a left concat. No, sorry, yeah, a right, whatever. We want to prefix the existing string with this, so we can't just use s plus equals because that would do it on the right hand side. We want to do it on the left hand side, and then num gets divided by 10. And what we want for bases, so we handled the case where it was I, V, X before. But the next one up is where we're dealing with the tens. We dealt with everything up to 10, now we want to deal with the tens, 10, 50, 100. Then when we've dealt with the tens, we need to deal with the hundreds, C, D, M. And then when we've dealt with those, we need to deal with M. This is where we'd have our 5,000 and 10,000 case. We're not going to get numbers that large because the input is restricted, so we'll just leave those blank. So first we deal with the ones digit because we work mod 10. So the 3 here, the 8 here, the 4 here. That gets converted. Then we deal with the tens digit. There is none here, that's a 0, so that just turns into an empty string. Here that's a 5, so we're going to take the half, and the second time we're dealing with half, that's going to be an L, so that's good, we're taking that. Here we're going to do it with a 90, and that's going to be with an X and a C. Sure enough, it's with an X and a C, and so on and so forth. So, let's see if I made any typos. Looks good so far. Let's do some more test cases. That all looks good. There's usually tricky cases like, oh, can't be 999. Let's do 999. Let's do 1001. See what those do. They're passing as well. CMXCIX, that's 999, and MI is 1001. So that's good. So the reason I added these test cases was, well, this is one less than a round number, so it's kind of going to stress a lot of our code. And this guy here is one off a nice number. So there's nothing in the tens, nothing in the hundreds. So it's going to stress our zero handling, which is always a little bit finicky. I am quite happy with that. Obviously, this breaks horribly for larger values. But I think that's okay. Again, the tests won't stress that. If we wanted to go higher, we just need to extend this list, and we should do a check that the input is within the bounds our bases can handle. So here, that's literally up to 3,999. In fact, let's add that as a test case. 3,999. We handle it correctly. 3,000, and then there's 999 again. All right, let's submit it. Excellent. Not too bad. Definitely harder than going the other way. It's much easier to take a Roman numeral and convert that into an integer than it is to take an integer and convert that into a numeral. In fact, this one is a medium, whereas if we go, I think it's down here, Roman to integer, that one's the easy problem. Yeah, so this is the harder problem. Fantastic, I didn't lose all my work. All right, I think that'll do it for today. Sorry, it's a bit of a rush one, but I have places to be, people to see. Thank you very much for watching. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.